Hello class, this is CSE-5250, Section 1, Week 11, Video 7, Spring 2023. Hopefully by now you've long since submitted your OpenMP benchmarks in which we had the sieve of Eratosthenes parallelized using OpenMP. Now the point of that assignment was not so much so we can find prime numbers, but rather so we can write a program that we can parallelize using hardware that we most likely already have. And that hardware is a multi-threaded CPU. A multi-core, multi-threaded CPU. So, as long as your computer was made with or built within the last couple of years, your computer should be already good to go with running an OpenMP program. And hopefully, and I would hope that you had benchmarks that showed the trend where if you had more threads, it would have reduced the execution time of your program to some extent. But anyway, we're going to move on to MPI. So these instructions are specific to a Windows machine and using Visual Studio. If possible, I would recommend following along using a Windows machine and Visual Studio because, well, that's how I learned how to use MPI. I would not know how to do this using anything else. This is just what I know. If you can find a way to if you can find a way to follow along using any other resources, then follow along that way. But these are the instructions for setting up MPI on a Windows system so you can make Visual Studio projects that use MPI. First, you go to this link. Now, this link is on Canvas. Now, this link is I shouldn't say this link is on Canvas. Rather, these instructions that contain the link is on Canvas. So you would click on this link, docs.microsoft.com/yada/Microsoft-MPI. You go to this link, it'll take you to this webpage. Go to MS-MPI downloads. You're gonna want to click on this, MS-MPI version 10.1.2. Click that. It'll take you to another page where it has a big red button that says download. Click that. It will ask you, what do you want to download? You want to download both of these. You would click next, and then it would prompt you where do you want to download these things. So if I click this, it'll ask me where I want to download these, and I would just say download these installers wherever you can easily find them. So by default, that would be your downloads folder. So I'm gonna cancel this because I've already had these downloaded. Once you have these downloaded, you need to run both installers. If I go to my downloads folder and type in MS-MPI, it'll show me that I have the two installers already. You would run both and pay attention to where these installers are putting files. By default, it should be somewhere on your C drive, but if you have to change the location, you need to remember where you need to remember where they're being installed. So I would recommend that by default you use the default installation locations. So that would be somewhere on your C drive. Once you run both installers, you should be good to go with the next step of making a C++ project on Visual Studio that uses MPI. You do these instructions every time you have to make a new project. So the reason why I'm going through this process step by step is because we have Visual Studio 2022 now. And there are a few small considerations, a few small changes that I have to explain, because sometimes there might be some mismatches in versions, and you might get the wrong instructions, and you don't know what, and you get a system that doesn't work, and you don't know what to do. So this is what I'm trying to prevent that headache right now. So let's just, now this is a pre-made MPI project already, but I'm just gonna start a whole new one. Visual Studio 2019 is what I have, but these instructions should be more or less the same on Visual Studio 2022. It's just that you have to pay close attention to a few subtle changes. So I'm just gonna create a new project. I personally like to create an empty project so I have more control over what files are being made. I'm just gonna say MPI Hello World. I'm gonna call it MPI Hello World Spring 2023. Because why not? Right click on source files, add, new item, and I want a CPP file. I'm just gonna call it main.cpp. Add. And now, the first thing we do, once we have a CPP file in which to write, is write in include mpi.h. And immediately we have a problem. Cannot open source file mpi.h. That's because we have to tell Visual Studio where to find this. Now, when we went through the process of installing these things, mpi.h and a few other files will have been already installed, but Microsoft Visual Studio does not know where they are yet. So we have to tell Visual Studio, we have to go into the project settings and tell Visual Studio, okay, they're under such and such folder. So, click the project tab, project name properties, that will be the last one here, under this drop-down menu. Click that. Configuration properties, go to C/C++. We want to go to additional include directories. Click this button here, edit. Click here, double click on it until you see this ... button. And then we can click that to add a new line. What we want to do is this. Wherever we installed those files from when we ran the installers, we want to find where they are. If you didn't change where, by default, these should be somewhere on your C drive, and that location is this. Go to this PC, C drive, program files x86, Microsoft SDKs, MPI. And here we have an include folder. Click that, select folder, click OK. Click apply. We're not done yet. That was the header files. No, that was the include directory. We also need to include an additional library. For that, click linker. Go to additional library directories. Click this down button here, edit. Same process as before. We add a new line, click the ... button, and then we get to select another directory. it's a similar path as before. This PC, C drive, program files x86, Microsoft SDKs, MPI, lib, and now we have to make a decision. Is your program going to be is your program a 32-bit program or a 64-bit program? How do you know which to switch? Well, if you look at the very top here, hopefully you can see this because I record these at a high resolution, like a high resolution than is convenient sometimes. But anyway, if you look somewhere on the top of your Visual Studio window, you'll see a little thing that says either x86 or x64. If it says x86, then you select x86. That means you're running a 32-bit system, a 32-bit program, I should say. If you are using Visual Studio 2022, it's going to default to an x64 system. That means it's going to be a 64-bit system, and in that case, you want to select x64 instead. That's one little difference. That's just one little difference that came up when some of us, the past time I taught this class, I've had a few students ask me, this isn't working, and it turned out it was because there was a version mismatch, and it was x64 when it should have been x86 or something or other like that. So pay attention to whether your project is set to x64 or x86, and then select the appropriate folder. Or you can just default it back to x86 and then just select the x86 folder. In my case, I'm going to select the x86 folder, select folder, OK, apply. We're still not done yet. Go to Properties, under Linker, go to Input. Click Go to Additional Dependencies. See this whole line? That's a bunch of .lib files. Click that. Click the down button. Edit. All we need to write in now is msmpi.lib. msmpi.lib. And that's it. Click OK. Click Apply. And now we're done. And just like that, Visual Studio now knows what mpi.h is. So now, at this point, we can get to work with writing a program. Let's start with the Hello World program that I've already pre-written over here. So, I'm just going to copy all that and paste it into here. Okay, so it doesn't know what printf is, but that's something that's under IOStream, so IOStream. Include IOStream, and that should fix that one problem. So when we write a MPI program, our int main function should have two arguments in it. Int star argc, comma character star argv. That's the one main difference. That's the one main thing we need to do to write an MPI program. So now you can just click on the debugger button and run it, right? Not quite. Yeah, we can click that, but it's going to default to running the program using one process when you want multiple processes. And Windows Defender Firewall has blocked some features on this app. Oops. I'm gonna allow access because sometimes you're writing a program and your antivirus system says, oh, we found this malicious program. No, that's my homework. Sometimes that happens, so you have to tell your antivirus, no, that's my homework. So, as I was saying, if you try to run this, it's going to run using one process. It says threads, but it really means, we mean processes. So I'm gonna do one more change. And yeah, we can use the debugger, the local Windows debugger, but it's going to run using one process. It's going to run using one process. So, how do we get this program to run on multiple processes? Well, first thing we need to do, build solution. Or hotkey Control-Shift-B. All these instructions are in the how to install MPI on Visual Studio file, by the way. So, we can't just run this using the Visual Studio debugger. We have to use the command line terminal instead. I already explained that you need to have int main, int star argc, character star argv. We had to build the project, and now we have to go to where our project file is and find the compiled executable. So when I built solution, it created an executable file that I now have to look for. I click here. In the Solution Explorer, click here where it says our project name, right click. Open folder in File Explorer. And now, we have our source code, that's our main.cpp folder file, and a few other things that's associated with Visual Studio. We go back one level by clicking this up arrow here, and then we go to a debug folder here. So I have to go back up to where the .sln file lives. We go to the debug folder over there, and right there is our executable. Next step, click the address bar itself and type in cmd. That's going to open command prompt that is at the location of where this executable is. And then we can just type in a command, npi exec -n. We can type in however many processes that we want. Let's do 16. And then we write in, as the final argument, the name of our executable. So we named our project NPI Hello World Spring 2023. So that's going to be the name of our executable. So NPI underscore Hello World underscore Spring underscore 2023 .exe. Enter. And now it runs using multiple processes. So now it works. And all that setup is necessary for our next assignment, and that is to write a multi-process program that produces a multiplication table. My brother has a video on how to go through that. He might explain the set of instructions on how to create a Visual Studio project on a Windows system. I basically did the same thing, but I explained a few differences between that and between Visual Studio 2019 and possible differences on Visual Studio 2022, but it's gonna be more or less the same. He explains what to do for the times table assignment itself. So basically you would follow that video and go through the process of making a times table, and that's basically your entire assignment for that's going to be the basis of your next assignment. After that is going to be applying that knowledge into how we can make a multi-process sieve of Eratosthenes. So this video is just a starting point for that. I might have to put out a secondary video for how we can go about writing the sieve of Eratosthenes using MPI. So what this video is, just setup. It's all just a setup. So maybe before I end this video off, maybe it'd be a good idea to walk through what's going on in the code. So when any MPI program that we write, we're gonna have to have a couple of functions here. Mainly it's gonna be the MPI com rank and com size, and the finalize function here. So I do have a PowerPoint presentation that goes through the MPI basics. So let's go through that presentation right now. Slideshow from beginning, and let's go through this slideshow together. I'll have this also on Canvas as well. So this is more or less the same exact Hello World program that I wrote back in Visual Studio. So let's just walk through it together. So when we run this program using that command in the command prompt, we have multiple processes being created, and each one is saying hello world alongside their process ID out of however many processes there are. So com size and rank. Com size is the number of processes there are. Rank, you can think of that as a process ID. As I explained before, we had to set up the main function so that it takes in arguments. We also needed a few functions. To get MPI up and running for our program, and those are MPI init for initializing the environment in which MPI can run, MPI com rank. This is so a process knows what ID it is, and MPI com size. This is so a process knows how many other processes there are. And at the end of the program, we have to call MPI finalize. And this is necessary at the end of every MPI-based program. So this is a basic Hello World program that has no message passing in it. We're gonna start doing message passing in the times table. So, well, when you watch that video, you'll know what to pass for those functions. Basically, there's a pair of functions. It's send and receive. Those functions take a whole bunch of parameters, something like 6 or 7 parameters. But the key thing to know is you must have the same number of sends as there are receives. Otherwise, the program gets deadlocked and it freezes. So, with that in mind, maybe you can do a sort of example on message passing. We can modify this program to send a string from rank 0 to all other processes. And because each process has a unique rank or process ID, we can use an if statement and a for loop to easily send and receive. So here's what that would look like. Rank 0, here we have the code for rank 0. We're going to use an if statement so that you can think of it as rank 0 as being the main process, and all the other processes are subordinate to the other, and all the other processes are just following whatever rank 0 asks. I don't know. Let me back up. So rank 0 is going to be our sender. All the other processes are gonna receive something from rank 0. So as I said, there's like 6 parameters for this send function. And those parameters are the address. In this case, we're going to be sending a string. So we're going to pass in the address of the string to send, the number of characters in the string, the data type of what is being sent, the rank or process ID of the receiver, the tag, which can be used to distinguish between different types of messages. We're just going to default it to 0. And the handle to the communicator, which we're just going to set to MPI ComWorld. All other processes are going to be receiving a string. So, if you look closely here, we have if rank 0, it's going to execute this code. Else, it's going to execute this code. All other processes are going to receive a string. Here, there are 7 parameters. The first parameter is the address of the character buffer. The second parameter is the number of characters in the string. The third parameter is the data type of what's being received. In this case, it's characters, so we have that set to be MPI character. Then we have the rank or process ID of the sender, the tag, which we just set to 0, the handle to the communicator, which we just set to MPI ComWorld, and the final parameter is the pointer to an MPI status structure. We can just set that to MPI status ignore. Okay, so our character buffer is going to be a null terminated. Basically, we're going to have a null terminated string here. So we know beforehand that our message is going to be some number of characters. We know that our message is going to be some number of characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yada, yada. So this is what? 13 characters? So we need a character buffer that's going to be large enough for the entire message plus a null character at the end. So I had to write in beforehand that we have a buffer that's of size 14. That's big enough to hold the entire message plus a null character at the end. So I had to make a... So if you read this comment here, it's the message being sent is already known to be 13 characters long, but it's plus 1 character because we have a C string that's going to be null terminated. So we can imagine reversing this. So you can imagine that where we send processes, we send from one process a message like that to other processes. But you can easily imagine a scenario in which we have to reverse it. So instead of every process receiving something, it's every process sending something to rank 0. Also, we're not limited to strings. We can use all sorts of data types, such as integers, floats, or arrays thereof. So yeah, this is an example to show how a Hello World program works. That was one without message passing. Oh, this PowerPoint slide also has some further reading on what these things do. So later on, I'll upload this presentation onto Canvas so you have a reference on what to do. So this is just a Hello World program, but we're gonna make it a little bit more complex. I'm going to code in all of this from the PowerPoint slides. So it's gonna be pretty simple. I am going to comment out this printf statement so I can write in if rank double equals 0. And this is going to be code to execute for process 0. Else, and then code to execute for all other processes. So I'm going to close this for now. And then I'm going to put the presentation on the side so I can easily refer to the code in here. I'm going to write in a message. Hello world, \n. The thing doesn't know what a string is, so include string and fix that a little bit. For int I equals 1. Because it's gonna skip itself. Rank 0 is gonna skip itself because it's not going to receive, it's not sending and receiving to itself. It's sending to all other processes. So we skip rank 0 and say for int I equals 1. I is less than com size. I plus plus. And then MPI send message.c string. That's gonna give us the address of this message. msg.length, which gives us how long our message is, comma, MPI underscore character, because we're sending characters, I, which is going to be the process ID, because we're iterating through however many processes we have. 0, MPI com world. For our last set of parameters. And that's going to be it for the code for rank 0. For the code to be executed by all other processes, we're going to write in this. Process %d is receiving a message from rank 0, and then you have to pass in the rank. It might be helpful to think of this as two programs that's kind of inhabiting the space of one program. So this code is kind of its own program, and this code is also its own program. It just happens to be the case that they're both in the same main function. So I'm gonna write in MPI receive. If we're sending strings like this, for whatever reason, it has to be a null terminated string. So however long the message has to be one character longer because it has to be null terminated. We want to write in, actually before we do that, I want to write in this. Character buffer of size 14, because we know how big it is. We're going to make that final character in the thing null. And then I can do MPI receive address of buffer 14, because we know this thing is 14 characters long. MPI underscore character, because it's a character data type. It's being sent from process 0 or rank 0, so 0. tag 0, MPI com world, and then MPI status ignore. And then printf, I can just copy this entire line. Process has received a message from link 0. And then we can just print out the message. We're going to make a whole new string that is basically our buffer, what we had from our buffer, and then we can just print out the entire string. And that should be it. So now we can run this program, and as I said, we're not going to use the debugger. We can't really use that because it's going to run using one process. So once again, right click, open folder in File Explorer, go back one directory level, and then go to the debug folder in that. If we went to this debug folder by mistake, what would it have? Well, obviously it's not going to have the executable file that we want. npi.hell. That's hopefully we don't have to go through hell for just to program a simple hello world program. So anyway, we go back one level and go to the debug folder in there. And then we have our executable file, cmd. And then we write the command to run this program, and that is mpi exec -n. The number of processes that we want to run, let's do 4. And then the name of our executable file, which is mpi hello world _spring _23.exe. Rank 0 is sending a message to all other processes. Process 1 has gotten the message and it prints out hello world. Process 2 also gets the message and prints out hello world. Process 3 also gets the message and also prints out hello world. You'll notice that there's no real order in which the processes receive a message. So if I ran this again and try it again with a bunch more processes, say 16, it's going to run the same program again, but with a bunch more processes, and there's no real order in which these things receive their messages. So if we run this again, the order is going to be different each time. So that's something to keep in mind when you are to run this thing. It's because we don't have any way of enforcing an order in which these things print. So it's just going to print it whenever. It's going to basically print it whenever. So that's going to be the basics of OpenMP. No, not OpenMP. This is the basics of MPI. We can change the program so that it sends a number instead of a string of characters. In that case, we would be sending just, if we were to send, say, a number, we would simply modify this thing to, let's try and modify right now. So I'm gonna move a few things out of the way and start modifying this code so that we instead send a number. And number, let's call it let's say the number is this. So say we want to send this number instead. If we want to send a number, we want the address of the number. The length is 1 because you're only sending one number. And instead of a character buffer here, we want number buffer. That's going to be an uninitialized value because that an uninitialized variable, because we're gonna pass that address into here. We only have one. Oh yeah, we have to change the data type because it's integers now. MPI int. So I can just copy that, paste that here because one process is sending integers and the rest are receiving integers. So if I build that and then go back to command prompt, first I'm just gonna do CLS to clear everything, and then I can just run the program again, and it didn't work. And that's because I didn't build it. So let me rebuild, and then CLS again, run again, and it printed out garbage. What went wrong here? Okay, the problem was this. It actually, I forgot. What happened was I forgot to change the printf here. So I'm just gonna quickly change that. So that was the one change that I didn't do, so I'm gonna save again, rebuild, go back to command prompt. So that random garbage here was just whatever the character buffer had in memory at the time. So with that fixed, let's clear again, and then run the whole program all over again. And there we go. And this is how we can send an integer value from one process to another. Eventually, we're gonna use these ideas, we're gonna use these principles to build up a whole new sieve using MPI. Because our final project is going to be to write an MPI sieve. This is gonna be a bit tougher than the OpenMP sieve because it's a lot more nitty-gritty than if we just had OpenMP. So this is just gonna be a starting point for what we're gonna do for the rest of the term. For now, follow through the instructions for how to set up a MPI times table. And then later on, we're gonna start figuring out how we can build up an MPI sieve. So that's gonna be it for this video, and we'll meet together next week. See you then.